So I'm pleased to introduce our three excellent speakers tonight, the three authors of Vermont's natural community book, Wetland, Woodland, Wildland. Liz Thompson and Eric Sorensen have been working on natural community classification together for, I think we decided 33, 34 years at dinner, a long time. Liz started working on classifications of Vermont natural communities in 1984. At which time there was just sort of a regional classification, and the first edition of the book was published in 2000. So we had a second edition come out with the edition of Bob Zano, the third author, in 2019. So just a little bit about our three authors. Liz has been working as the Director of Conservation Science at Vermont Land Trust for 19 years. She grew up in Massachusetts and studied botany at the University of Maine, University of Vermont, and the University of Michigan Biological Station. I was lucky enough to meet Liz when she was teaching field botany through the Field Naturalist graduate program here at UVM, where she taught field botany for 20 years. And Liz's second favorite sedge is Trichophorum alpinum. We may hear about the first sedge later this evening. So Bob Zano works as a community ecologist for Fish and Wildlife. He's been with the state for 14 years. Bob grew up in New Jersey and got kind of hooked on natural community ecology, exploring a basalt dike near his house where there was a chestnut oak woodland atop the ridge. Bob studied biology at Bowdoin College and here at the Field Naturalist Master's Program. Bob's an avid climber and paddler and lover of all heath shrubs and all things alpine. And I've recently had the great joy of teaching field botany with Bob, trying to fill some of Liz's shoes teaching sedges here to the new field naturalist cohort. Lastly, Eric Sorensen, he is recently retired from his position as a natural community ecologist with Fish and Wildlife, where he worked for 25 years. Eric grew up in Michigan, Holland, France, and Spain, and when he first saw patterned fen in northern Maine, that's when he was hooked on natural communities, and he ended up doing a master's project on patterned fens at the University of Maine, Anna. Eric has a great knowledge of mosses, especially wetland mosses, and his favorite is Paludula sporosa. Great choice, Eric, and great moss of rich fens here in Vermont. Eric began working on the first edition of the book with Liz in '96, and I just admire your partnership so much. We're so lucky to have you speaking tonight, so thanks.
Thank you, Grace. Thank you so much. Thanks everybody for being here. And I am Liz Thompson, and we are going to talk about some of our favorite natural communities of Vermont, basically is what we're going to do. And also talk some about their conservation. So I'm really happy to be here with you, and I also just want to say that the New England Botanical Club was a really important influence for me early in my career, and I really, it's a special pleasure to be with you. I don't know your name has changed, but it's still the club to me. So. It's great to be here and with you, so thanks. So we're gonna just launch, and I've got actually a lot of slides, and I'm gonna go through them fairly quickly because some of them are just pretty pictures, and it's sort of like I don't know if this ever happens to you, but does your phone ever wake you up at night and say, I've got a slideshow for you? It did that last night to me, and it had to do with some of the slides that you'll see today. But I'm not going to do it. But I'll go through quickly, sort of like that, this sort of slideshow format. So, a natural community is an interacting assemblage of organisms, their physical environment, and the natural processes that influence them or affect them. And this is the cover of the second edition of our book. The project has been a partnership between the Vermont Fish and Wildlife Department, the Vermont Land Trust, my employer, and the Nature Conservancy, which is where I was associated when I first started doing this work back in the maze. Just a little bit of basic Vermont geography. This is a geological map of Vermont that has been, that we classified the bedrock geology of Vermont based on ecology. So this is not a map that's based on rock ages, but on ecology. And so everything that's blue on this map basically is calcareous bedrock. And everything that is brown or green is generally not. And so, for example, the green up in the northeastern part of the state, that's mostly granite plutons, whereas in the southern part of the state, the green is Precambrian rock. So just putting this in context, in this regional map from the Nature Conservancy, yellow is actually calcareous rock. And you can see that Vermont has a disproportionate amount of that compared to other states in the regions. And so, you know, it's not that Massachusetts or Maine doesn't have calcareous rock. New Hampshire even has maybe none. Not very much. But anyway, we do have a disproportionate amount here. So that's one of the things we're going to focus on here. And then this is a map of the superficial geology of Vermont. Again, generalized. This map was sort of generalized and made for the publication of Wetland, Woodland, Wildland. And I'll refer to this in a couple of minutes. But I just want to start with one of the natural communities that is right here on the lakeshore of Lake Champlain, which you can go visit if you want while you're here. And this is the limestone bluff cedar pine forest, an uncommon natural community that occurs really in just a narrow band along the lakeshore, right along the bluffs on Lake Champlain. This is a wonderful illustration by our illustrator Libby Davidson, who did all the natural community illustrations in the book. And this is just so you can see from a distance where that natural community occurs. And this is at Lone Rock Point here in Burlington. What it looks like in the interior. And some of the trees can be huge. Some of the trees are big. How do they cling to the rocks like this? How do they live like this? Where do they even get their nutrients in a situation like this? Who knows? But some of these trees are very old. And this is one of the influences in the winter. One of the things that happens in winter, that there's a heavy ice load on some of these trees. Here's Bob coring one of these trees, one of these northern white cedar trees, which doesn't look particularly big, but it turns out to be, well, I can't remember, Bob, but at least 100 years old, that particular tree. This was in Isle of Lamont. And if you look at this, cross section, which we didn't do, but we found, you can see that the rings in northern white cedar on these bluffs are very tight. They grow very, very slowly on these bluffs. And in that last site, some of the trees there are 300 years old. Similar situations in the Niagara Escarpment have trees that are up to 1,600 years old. Extremely old trees. And some of the things that grow in this natural community, this is in fact my favorite sedge, ivory sedge or ebony sedge, Carex eburnia, which actually means ivory, but a lot of us call it ebony sedge. There it is in the springtime, flowering, and there it is later in the year with its shiny black perigynia. Really distinctive sedge. And this was illustrated by Betsy Brigham, one of the illustrators for our book. For the book, so she did a lovely illustration of this plant. Another plant that grows in this natural community, a common one, is common columbine, walking fern, and maidenhair spleenwort. And for each of the natural communities, we have a list of the rare plants that might occur there and the rare and uncommon animals that might occur there. So there's a lot of rare species that occur in this community, including this ram's head lady slipper. Just a little bit about northern white cedar, and this is sort of, Bob will take up on some of this later, but just, we are really kind of at the southern range. It doesn't have a northern white cedar does not have a large range, and we're kind of at the southern range limit here. In fact, this range map shows more northern white cedar in Vermont than actually exists. It's not in the central part of the Green Mountains much at all. And there's a couple little spots in Maine and in Connecticut, and actually down the Appalachians, but it's not common here. And this is a book from 1853, The Natural History of Vermont. This tree is found growing only in swamps and along the rocky banks of streams and ponds, is what he said. And that's sort of true here in Vermont. It's really in wetlands and in very wet and very dry places, but not in between. And here's a seedling of northern white cedar in one of these situations. You can see the seedlings have these little leaves that are very distinct and very different in form from the mature leaves. One of our other natural communities, another favorite one, which some of you will be visiting tomorrow, I think, is Lake Sand Beach. And this is Alberg Beach up in the islands, up in Alberg, Vermont. And look at all that vegetation on that beach. It's just so beautiful. It's just lush with vegetation, all kinds of fascinating, interesting things. And thankfully this place is protected now. One of the interesting plants, clammy weed. And there's a close-up of clammy weed. But wait, that's not clammy weed, that's a flat sedge, right? What's that actually a picture of? And there's two different flat sedges that look very much alike that grow on the beach. Shining flat sedge, and then this one, umbrella flat sedge. You can see the difference between them in this photo, which I think was taken by Matt Peters, Grace thinks. And that's a rare species in Vermont, but these both grow on that beach in Alberg. Another one, Ond flat sedge. And here's one of the beaches when the water, occasionally when there's a very dry year, the water will drop way, way down and there's vast areas of exposed beach. And really it's mixed with wetland, it's mixed with marsh. And this is an example of one of those places. This is a place in Colchester, not far from here. And this was a photo from 2016 when three people were inventorying. This is actually a news piece. They were out there looking for rare plants on this drawdown beach, and made it into the local news because it was kind of a cool phenomenon. What were they looking for? A couple of these things. One of them was creeping lovegrass. Another one was the very rare Wright's spikerush, Elaeochorus diandra. Another one thing they might have seen there would be this weak-stemmed bulrush. Another natural community associated with the beaches is sand dune. We actually have a little bit of sand dune in Vermont. And interestingly, there's people in this room who know way more about this than I do, but it has some plants growing on the dunes. There are plants growing on the dunes that are what we call glacial disjuncts. They are things that came in here into the Champlain Basin when there was a marine invasion called the Champlain Sea, and they have stuck around since. One of them, and this is actually a picture of, you're looking out at the lake, and a picture showing the activity of the dune, that the sand in Alberg, the sand continues to move inward and actively move every winter. Into the interior. There's Bob Popp again inventorying this dune a couple of years ago, and Champlain beachgrass, which is now considered a subspecies, and that's a typo, shouldn't be fallacy, but subspecies of the coastal common beachgrass. And it has some different morphology, different flowering time, and so forth. Another one, interesting one, is beach pea. And this is not one of the disjuncts, but this is beach wormwood, which is a rare species in Vermont that also grows there at the Alberg dunes. And this actually brings to mind a trip that I took there a couple of years ago with Kathy and Dave, where Dave was, I think, the first one to spot this on the beach that day. Now, looking back at our surficial geology map and zooming in on it a little bit, if you look at the legend there and the map here, you can see that in this area, we are on gravels and sands. Burlington is right here. And whereas to our south, we are on silts and clays. So just for reference, another natural community that's really characteristic of this area, which some of you will see tomorrow, is the Pine Oak Heath Sandplain Forest, and that is a picture of pitch pine with a student in the field naturalist program, Andrea Urbano, who actually now works professionally as a forester in Massachusetts. And there's a couple of interesting papers that have been published on this. And one of them is the reforestation of sand plains in Vermont, which was published in 1910. And another one by Tom Sikkema, the pre-settlement and present forest vegetation in northern Chittenden County. The first one, in that first paper, there's this really interesting map of the deltaic sands that were deposited at the mouth of the Winooski River when there was the sea level was, when there was Champlain Sea here and the water levels were higher, and also at a couple of different lake levels. And so the place that we have often visited with students is right in here on what's called the Colchester Delta. So deep sand deposits, and from these two papers, a couple of quotes. The first one from 1910, he says, pitch pine succeeded to the control of areas from which the dominant white pine had been removed. White pine, however, is gradually regaining its control on cut-over areas. The second one, this is from Sikkema in 1971, where he was looking at pre-settlement records, and he said that the pitch pine oak forest occurred on sand plains in Colchester and Burlington. And I'd love to go into this some more, but basically the first author was saying that pitch pine was kind of a little bit of an anomaly, didn't really belong there. What really belonged there was white pine. And whereas Sikkema said, no, actually there was pitch pine in the sand plains, looking at pre-settlement data. So interesting, very interesting. What we sort of don't know really about these natural communities is their fire history. In any case, they occur on, this is a soil diagram from a soil survey showing these deep sands, Adams and Windsor sands, over clays and silts and mucks. And there is a soil pit there with some students looking at it, very fine sandy soils. And there's a very dedicated student studying the natural communities in her natural community book, trying to figure it out. And this photo shows the fire. This sandplain forest is managed using fire. Has been managed using fire. Some experimental burns out here in the Colchester sandplain. Just sort of as an experiment to see what would happen. And this is what it looked like afterwards. And here's what it looked like a couple years beyond that, after the burn. And there, can you see what that is right there? That's a happy carrot. But so you can see the openness of the area after the burn, but a few years later. So there's the pitch pine bark again there, and then on the right. Another interesting tree that grows in the sandplain is black oak. Not particularly common here in Vermont, but common in the sandplain. One of the rare plants is harsh sunflower. Now check out this photo and see the out of focus part of it there. I'm going to change the focus. There's the harsh sunflower, and there's Vincenza Way, which is a new development in Colchester. A friend of mine lives there, and she's helping to monitor, but she actually discovered this little subpopulation of the harsh sunflower right at the head of her street. And the plant is protected there. But this Vincenza Way is built on the sandplain. It's built right in the sandplain forest. And so because of our endangered species law, we were able to set that patch of harsh sunflower aside and protect it. Now going to the clay soil to our south, one of the characteristic natural communities of Vermont is the clay plain forest, and it's really an ecosystem of different vegetation, different natural community types, wet, dry, etc. But there's a photo. This is my mitten just for scale. And the soils are shallow. The trees are shallow rooted. The soils are not shallow, but the trees are shallow rooted because the soils are saturated. And there's a down tree with a group of students in front of it. You can see how that happens frequently in this forest. This happens to be an old forest in Charlotte, Williams Woods, one of the few really natural remnants of the very rare clay plain forest in Vermont that did occupy the whole Champlain Valley, but is really reduced to a small amount now. And you can see the roots close to the surface, huge trees, white oak, bur oak, and a lot of standing dead trees in this forest, down trees. It's a beautiful forest, and one of the characteristic species is barren strawberry. Well, Geum fragarioides. I wanted to say Waldsteinium, but darn, I can't say that anymore. And thanks to the Nature Conservancy for protecting this land. Speaking of the Nature Conservancy, I can't leave without saying something about Chickering Bog, one of our beautiful fens in Vermont. And again, now moving out to the eastern part of the state on calcareous soils out there, very different geology, but calcareous soils. And so this is a fen, a groundwater fed system with some amazing plants, showy lady slipper, grass pink, rose begonia, horned bladderwort, which isn't rare, but it's really cool. And this is a photo by Emily Stone, who's a former field naturalist, and she took this great photo of the bladders under at the base of the plant. Water avens, not a rare plant, but just a fun one to see. And there, my second favorite sedge, alpine cotton grass. And a close-up of that. Well, having gone out to the eastern part of the state, let's see, where are we? One final thing is mud sedge, Carex limosa, which, I don't know, can I change my mind about my favorites? I love this one too. But in any case, I will leave you there. But since we've gone out to the eastern part of the state, I'm going to turn it over to Bob now, who's going to talk about some other stuff in that region. So here you go, Bob.
All right, thanks, Liz. I've learned a lot from Liz starting when I was in the Field Naturalist program. And I just learned something tonight, which is always put the names on the slide so you don't get caught.
That's why I do it.
I didn't do that. And so we'll see how I do. I wanted to start with kind of parallel to Liz's presentation and start with cedar again. And here in the northern white cedar swamp, the other place we find northern white cedar in Vermont. And these are, actually this one's kind of bright, but cedar swamps are often dark, shady places with that foliage, and they're in shallow basins, and usually there's groundwater seepage moving through the swamp, bringing nutrients from the rich bedrock through the organic soils. Here's northern white cedar up close. I love those flattened stone needles. And when they're not dark and continuous, there's sometimes all sorts of natural disturbance, like this wind throw event here in this northern white cedar swamp, making some openings and new light. And when the cedar is knocked down, it uses this process called layering, where it can reroot and establish new growth. Ultimately, that connection between the original stem that fell over, rerouted, that connection can be severed, and you can have two trees where there was one. These cedar trees can get big, they can get old. Just like the cedar bluffs have old cedar trees, cedar swamps often have old trees. They also get really mossy, and there's all sorts of great bryophytes in these swamps, like stair-step moss, here illustrated by Betsy Briggins. This is, I think, a Physidens moss, and I just love this photo. I don't really know what it is, but maybe someone can tell me more about it. Physidens here, does that seem plausible? Sphagnum Warrenstorffii, characteristic cedar swamp moss. And then looking at other trees, stepping back up and looking up in the sky, you might find black ash, which is common in these seepage swamps like northern white cedar swamps, but uncommon elsewhere in Vermont, not super abundant. It's not on our uncommon plant list, but it's not a very common plant, and unfortunately it's probably going to become less common because of the emerald ash borer. A species of great cultural importance, of course, for basket making. This is familiar because I know Liz had this same photo for the cedar pine bluff forest, but this is also a rare plant of the northern white cedar swamps, the Ram's Head lady slipper. Calypso, which I think unfortunately was last seen in a cedar swamp in Vermont, going on 20 plus years ago. So hopefully still out there somewhere. And then this one that I've never seen in flower, and maybe doesn't flower in Vermont very often, I don't know, but the Arctic sweet coltsfoot, Pedicites. Here's some of the other rare species associated with quite a few. I work for Fish and Wildlife, so I have to, it's like required that I have to talk about animals. Not really, but this was neat. I was in this cedar swamp and I found this stripped bark that, I mean, you can see how fresh the wood is underneath. This had like just happened when I was out there. And I was really puzzled by this. I didn't know what to make of this. And then I found the first clue. Can you see the scrapes on the bark there that happen to match my fingers there? And then I found the real giveaway clue. You see the track there? So bears had been stripping the bark, and I think it was probably to get into the oily, or to get their scent glands from their hands into the wood and probably mark the tree as some kind of territorial marker, as I understand it. Like say, I'm here. If you're near northern white cedar swamp, you might also be near a rich northern hardwood forest. These are common in Vermont, which is really neat, and they reflect our abundant, rich bedrock. But they're not only found on areas of rich bedrock. There are places, cove forests, where that downslope movement of soil, water, and nutrients all collects and concentrates, and we get these wonderful rich northern hardwood forests. This is an old example from Robbins Mountain, which is not far away from here in Richmond. Big sugar maple trees and a very lush understory. I think that's mostly Laportia wood meadow in that picture. Here's field naturalist students digging a soil pit and looking at that rich black soil that, because of that constant movement, you don't find the layers like you usually see in soil. You just get this almost undifferentiated, rich, dark soil. You can sort of see that pile of it on the left there. Some of the plants in rich northern hardwood forest, Goldie's fern, blue cohosh, and as I was putting this together, I realized this was drawn when there was only one, and now we've got to figure out, is it Caulophyllum thalictroides or Caulophyllum giganteum, and I welcome input on that.
The latter.
All right, there we go. Large flowered bellwort, Carex platygynia, or seersucker sedge is one name for it because of the wrinkled leaves. Maidenhair fern. So that's the rich northern hardwood forest that we can find anywhere. If we, in this area on the blue bedrock, let's see, is there a pointer on this? Yeah, there we go. In this part of Vermont, where we have our rich limestones and marbles, we get a different type of rich forest. It's not a northern hardwood forest, but reflects the warmer climate of the Champlain Valley and the more southerly species in that area. And we have a dry oak maple limestone forest where the soils are very shallow, maybe only a few inches of soil, So it's not that colluvial process, but it's the rock providing the nutrients. And dry forest, but very rich. Great place for spring wildflowers. And a great place to see this is at Niquette Bay State Park, which is only about 20 minutes or so from here. So here's bloodroot, sharp-lobed hepatica, Trillium grandiflorum, and leatherwood. This is great. This is Liz's photo. Some ferns, baldwin fern, which can form huge carpets over the areas of exposed rock. And then, I saw this one already, but why not see it again? Walking fern. Again, on those exposed rock surfaces often. Now we're going to take that rich forest and we're going to tilt it vertical and go to a very cold place to see a boreal calcareous cliff. And I think this may be my favorite natural community of all. This is, we call it boreal, but Vermont's not really in the boreal region. That's further north where black spruce dominates. But we have these communities that have this very strong affinity and to the boreal region, and species where the heart of their range is in that boreal region. And so you can see that reflected in the distribution of this community in Vermont. And really this map makes it look like there's a lot more of this than there is. There's some examples up here, some examples here, and one or two here, and then this outlier at Mount Equinox, which is kind of interesting. But there's two really great examples of this. One at Lake Willoughby on the cliffs of Mount Pisgah, and that's this picture here. And can you find the botanist in this picture? Look closely. There he is. There's Bob Pop. The other great example is in Smuggler's Notch, the sharp cleft in the mountains. Here's another picture with botanists for scale. You may recognize these two. There's Kathy and Dave. On an exceptionally dry day, you can see that cliff is totally dry, and that's atypical for these boreal calcareous cliffs. They're often very wet. That's a little more, that was taken after this most recent rain, but these cliffs are often dripping wet, and that running water is carrying that calcium that might be in rock veins, and it's moving it over the face of the cliff. So the cliffs at Lake Willoughby are on limestone rock, the Waits River Formation, but this picture in Smuggler's Notch, the rock is not a limestone, it's a schist with thin bands of rich rock in it, and I think this water is moving that calcium out of those bands and onto more of the rock to create this really enriched habitat all over the cliff. They're dripping, but if you can get under an overhang, the lucky botanist might be able to find a dry place to look at plants. And all that water, of course, makes for really dramatic scenery in winter. And of course, the mountains get an enormous amount of precipitation. Mount Mansfield gets like twice the precipitation of Burlington, so much of that is falling as snow. So these are tough places in the winter. They're kind of like vertical fens, and there's some fen species like Calms lobelia, grass of Parnassus, and then some just really wacky stuff, like butterwort, which is a carnivorous plant that has these sticky glands and traps insects. You can see some of them on this plant here. In real life, it's not that big, so you don't have to be worried. They're not getting you. Wonderful flower. You can see those. Look at those glands on that. Purple mountain saxifrage. We have 3 mountain saxifrages associated with these cliffs. This one is a cushion-forming plant, and sometimes those cushions will just kind of drape over the edge of the cliff and hang down. Here's one of the others, white mountain saxifrage, which is named for its flower color. It has nothing to do with the White Mountains of New Hampshire, where that name came from. The white mountain saxifrage. And this has, those white dots are calcium exusions on the leaves. And there's some research that suggests that those calcium crystals are actually focusing light and enhancing the photosynthetic ability of the leaf. I can't begin to explain the physics behind that, and I don't know if that's been replicated or found elsewhere, but it's really intriguing. And this is also a plant that can photosynthesize in the winter when it's above freezing, so like in this photo. And I think it's something that can just give it all the little extra edge it can get in this harsh environment. Primula mystacinica, I think in New England found only at Lake Willoughby and on the St. John River. Certainly only on Boreal calcareous, but maybe there's a few other sites that I'm not thinking of. Pale painted cup, Carex scripoidea, a dioecious sedge with separate male and female plants. Fragrant fern, the most northern of our ferns in Vermont. Our fern in Vermont that has its most northern distribution. I kind of mangled that. Hopefully that made sense. Not a plant, but here's the obligatory animal. Have to love the peregrine falcon, which can be on these cliffs. Getting into these places is not easy. And actually, these Boreal calcareous cliffs were some of the first places that attracted botanists in the early 1800s. And there's these reports of them just scrambling all over cliffs. Some of these are probably in Rodora, right? So these places have been heavily botanized. We know a lot about them, and I think there's still a lot more to learn because of how hard it is to get around these cliffs. And just one example, there is this plant, lance-leaved arnica, that was seen in or near Smuggler's Notch about 100 years ago, and hasn't been seen since. And it's not a people have looked for it and haven't found it. So there's been effort. It's not an easy thing to miss. I mean, it's not like some cryptic graminoid or moss. It's this nice showy flower, so it should be something that we could find. But it hasn't, and so one possibility is that it sadly could have been extirpated. The other is that it's somewhere up there, and we just haven't gotten to that place. And I kind of like to take a hopeful view that there are these plants and species that just live their lives and they're free from all this interference from scientists and rock scramblers and everyone who wants to go look at stuff, and they can just live in these wild places that are not really that large, but their wildness comes from their inaccessibility. And I think that's just a cool aspect of this natural community. So here on these cliffs, thus concludes our tour of some of our favorite natural communities. And now I get to hand this over to Eric Sorensen. And I guess I just want to say, Eric and I worked together at Fish and Wildlife for a number of years, and we would always very closely coordinate our conservation messages to ensure that we were, we were consistent with each other and that we were consistent with the department. Now Eric has total free reign, and I have no idea what he's going to say. So we'll all see together.
Thanks, Bob. It's great to be here, and I just want to say two things. Starting first, what an honor it's been to work with Bob and Liz for years, and the other is how important Rodora has been to me as a journal since my grad school days when I first started reading articles. And I've always liked its format and the great articles that are in. So I'm going to do something totally different, and I think this might be one of my only pictures of plants, and the rest of it is going to be more about conservation. But I want you to know that the whole time I'm thinking about plants and their welfare, and what we do about plants and all the other things that we want to keep around. So we've been talking about natural communities, and I hope you have a sense from the ones that Bob and Liz described how many species are associated with each. And some have very specific species, and some have more general species like sugar maple. But here we've got alpine meadow and a pitch pine and red oak forest, a red pine forest in the wetland, and rich fen with lady slipper. And rich fens have so many species, like a square meter plot can have 50 or so species of bryophytes and vascular plants. So natural communities are cool. They're documented and classified across New England, across the Northeast. And I think the Northeast is kind of ahead in that regard, in that we have a really good system of classifications in all of our states. But I want to back way out, like way out, and think about this place as you know, a pretty nice planet, one of the best I know, and you know, green forests and some deserts, lots of ocean, clouds, a wonderful atmosphere that protects us, and what a great place this is. And but we know all these photos are from NASA, but we know that our footprint on the planet is increasing. This is a composite image of lights. You've probably seen it before. Lights across the globe, and you can see where we concentrate, and it gives you a sense of our impact, of our footprint. And so what I want to talk about is what do we know and what do we do about that, both in the Northeast, in New England, and globally a little bit. Climate change is one of the factors that's affecting us now, but it's sure also our continued expansion into new areas, whether it's tropical rainforests or temperate forests like we have here. We're losing ground on important places, or even common places. Greater storms for climate change, desertification, melting ice flows and polar ice caps. And in the Northeast, we have things, common things like forest fragmentation, climate change with all of its effects of temperature and changing precipitation patterns and storms, and invasive, non-native invasive species sort of spreading. The one thing that's kind of, it's hard to say anything good about climate change the way it's going, but it's really made us think differently about how we want to conserve all species. We used to think about a plant here or a natural community here, and we know now that that approach won't work. That you know, prior to our being here, people being so abundant on the landscape, species could move along much more freely. We've created all kinds of fragmentation that make it difficult for species to move. But along with that, and we have this rapid climate change. We know now that species shift independently. Bob and Liz and I joke about our book will be out of, it won't mean anything in another 100 years because species are going to shift around and the classification will be different. You know, communities will reorganize to some extent. So one of the things we need to think about is how do we keep the landscape connected? How do we allow species to continue to move? And ecological processes. And there's been this focus on how do we conserve nature's stage, the physical landscape. If you think of the physical landscape, bedrock and slope and aspect and those sort of things as a stage, and the species moving around on it, you can think the species are like the actors on the stage. The stage is permanent. The physical landscape is permanent. So we have to think about how do we conserve that physical landscape. So we know what to do on a lot of fronts. Human population is increasing. We keep consuming more and more resources. We don't have good social justice and equity, and we don't have good enough landscape conservation. And you can guess which one of these I'm going to talk about, because I wouldn't touch the top two with anything I know. But I think we know more and more about what to do about those more complex issues too. So landscape scale conservation. What I wanted to do is just run through, you're probably familiar with many of these, but just as kind of a reminder of how many good tools are out there now that I think this is both recorded and the presentation will be available later. So you can look any of these up if you want to check them out. Wildlands and woodlands, farmlands and communities is something started in Massachusetts by David Foster, I think mostly, at Harvard Forest. And it's a charge to permanently protect 80% of New England. in different categories. Some reserves, some working forests, some farmlands, and some other. The Nature Conservancy, Liz showed a slide, another one from this mapping tool. They have a whole program really started by Mark Anderson, Charles Faree, and others at the Nature Conservancy in Boston. That's now a nationwide map and expanding into Canada of a set of places that are resilient to climate change, they have recognized biological diversity, and they are important for connectivity. And as a tool, this provides us a guidance that goes, across our region here and across the whole country. So it gives a framework on how we can do this kind of work. Another one is E.O. Wilson, who we lost last year, the Half Earth Project. And this isn't as guided in you should do this here or you should do this there, but it provides another framework and a call for 50% of the earth to be set aside as reserve for living things, all living things. One more, Staying Connected initiative. It's mostly an Adirondacks to Maritimes project, and it is mostly focused on connectivity, landscape scale connectivity, with several areas identified in Vermont and other places across the region where we should focus because connectivity is at risk. And then I want to talk but briefly about the Vermont conservation design that Liz and Bob and I and many others have worked on. And I actually think this is, although it's just for Vermont, it's something that it's a practical approach on how we can protect biological diversity by protecting this ecologically functional landscape that I'll describe. It applies a coarse filter approach, which the idea of that, if you're not familiar with the term, is if we can select the right kind of units that are big scale units, like a natural community, and conserve good examples across their range, we will protect the species that come with each of those features. Like if you protect the northern hardwood forest, you get that set of species. If you protect those boreal calcareous cliffs, you get another set of species. But what we've learned is natural communities is not enough. It's not a big enough coarse filter. The other thing that's good about this project, I think, is that it uses really recognizable features, something you can walk out and say, now I'm entering a forest block that's contiguous, or now I'm in a riparian area. It depends a lot on conservation, but also stewardship and management of land. A lot of folks were involved in this project, and it's continuing to evolve and with better mapping and that sort of thing. This is what the map of Vermont conservation design looks like in Vermont. Everything that's a color there is something that's a priority area. It's 60-some% of the state. That's a lot, but it's not a call that all those areas need to be reserves. It's a call that we need to protect the ecological function of all those places, which is a very different thing than saying they all need to be set aside. So an ecologically functional landscape is one that's intact, it's connected, and it's made up of this set of coarse filter features, which, if appropriately conserved and managed, for their ecological functions, offers high confidence in maintaining biological diversity and ecological processes in the future. It's sort of a tall order, but I think we have a pretty good sense of what to do with it. And it's applied at several scales, mostly the landscape and natural community scale. This is really the fine filter part. For those species that aren't captured by those other tools, we need to deal with them separately. I'll go through some of these just very briefly. At the landscape scale, there's a set of large forest blocks. You can see they're not all connected, but those are the places where the interior forest is really important for species that require space, whether it's a mammal or, well, it's mostly mammals, but it's also for ecological processes that occur on larger scale. The connecting forest blocks you can see they form continuous pathways across the state. You can think of them as stepping stones where species can move across the state over time and to adjacent areas. Surface waters and riparian areas are pretty much all rivers and streams, And they're the physical landscape diversity, which is a sort of a complex part of the project, but every red area was added so that we fully represent all the physical landscape diversity in the state. This is a slide that Charles Faree did actually quite a few years ago. It's an image, a model of Mount Mansfield. And there are some of the physical landscape diversity features that we tend to think about. This is a map of landforms. You can see those in this side here. And what I wanted to just mention about that is if you think about a place like Mount Mansfield, it's topographically diverse. It's got north slopes and south slopes and ridges and coves. And if you think about a plant that needs to move because of climate change pressures, a place like this is a place where the movement doesn't have to be all north. It could be around a ridge onto a north-facing slope where it's cooler, or down a valley where it's moister. So there are all these different sort of microhabitats in a place like that that make these topographically diverse forest blocks especially important for climate change resilience. At the natural community scale, this is a map of a few years ago of all the natural communities that are mapped that are sort of targets in the Vermont Conservation Design. There are more to be found by far, and there are sort of target numbers of how many we should have. These are sort of special aquatic habitats like high elevation streams in the Lake Champlain, which is kind of a wonder, and the lower stretches of some of the rivers that have important fish populations. And all wetlands. Oh, and bats and caves. We don't have maps for those because they're kind of secret areas, but those are really important not just for bats, but for all kinds of other things. This is one where we don't have maps of where the actual feature is, but we have targets, amounts for each. Young forests, for the birds especially that use young forests. Old forests is one that's super important now, that we figure out where to establish old forests of all of our matrix forest types, all the forests that occupy large areas, and have those as benchmarks so we understand what forests are like as climate changes. And they tend to be places that are most resilient to climate change and to the invasion by non-native species. Grasslands are sort of outside those forest blocks. They're places that are especially important for bobolinks and other grassland species. So that's the Vermont Conservation Design. And it's this intact, connected, and diverse landscape. It conserves species and communities, and it gives us a pathway to climate change adaptation over time. It does quite a bit more than that, though, too, and I think this is something that all of us that worked on it as kind of the science geeks thinking about just biodiversity, it's also something that we recognize as why we're here, anywhere in the Northeast. You know, this sense of place, but also things like working farms and the products we get from them, and recreation, and just sort of the inherent value of nature itself. Just a couple things. This is a vision. There's no teeth behind it. It's something we have to decide we want. Any of these, not just the Vermont Conservation Design, but any of these approaches, and we need to act on it. A lot of the Northeast is privately owned, so we have to make this work for landowners, so landowners can afford their property and can manage it with the future in mind. We need to have all these features in the Vermont Conservation Design, not just a few of them, all of them, and we need to come up with a balance of uses among those features. This is a really important part, especially for some of the features like maintaining natural communities and for old forests. We need permanence in conservation, which is a difficult thing to obtain. You know, but it's got to be an easement that works over a long period and that provides stability both for that place. And the stability is more than just for the natural community. We've got to figure out how to come to a stability in how we use the state and the region and the globe, I would say. Vermont Conservation Design, like some of the others, could be applied in a wider area. So this is. I just wanted to end with this, that on unlike, we tend to think about climate change and conservation now, and a lot of the words we hear about electric cars and carbon footprint and those kind of things. And that's incredibly important. But we hear less and less about conservation of nature and landscape scale conservation. And I just want to make the point that it's important that those features, which are, unlike social norms or cars, it can't be replaced once we've lost parts of nature. It's a one-way street, and then it's kind of done. So we need to take action on this, and we know what to do. And I think that's the part that is sort of yelling at us. And I just wanted to end with that all of us and friends and everyone, we need to sort of speak up, whether it's to, this is the part that Bob needs to not hear because I'm going to say things that Fish and Wildlife might not like, but we need to speak up, whether it's to our working staff or to elected officials or to people that we elect, that we want this done, because it tends to get sidelined because it's not screaming at us, and it's going to be gone if we don't take care of it. That's all my ranting, and I think all of us can take any questions about natural communities or not about social justice, please. Yes.
I've never done it. I'm told that Lake Willoughby is a great ice climbing site.
Bob probably has.
I have not, but I think it is maybe the premier ice climbing spot in the Northeast. And I worry about that because of the plants. And I think if it's thick ice, the plants are probably well protected. It's when climbers go out in the winter with their sharp, they've got spikes, ice axes, and spikes on their shoes, and they're kicking. I think it's when they take that out onto rocks and frozen moss that's a potential threat to those very rare plants.
Yes.
In the decades that you've spent working on this edition, but also the first edition of Rutland Woodland, what changes have you seen in the way that people are approaching landscape level conservation?
Bob, Liz, you should answer too, because Liz has been involved in, I think, every biodiversity conservation effort that's happened in Vermont.
I'm just gonna get up just for ease of.
Well, one thing is that landscape scale conservation was not really talked about much, and I think the first edition of the book, we might have mentioned that there was climate change, but we didn't have much to say about it. And it's like a driver now on how we think about what to do.
And when I started doing this work, I'll answer the question because I'm the oldest one here. And
Just there.
but when I first, actually in Maine, when I first started working on this stuff in Maine, I was assigned by the Nature Conservancy to do a biodiversity scorecard for the state of Maine, and it was about 3 pieces of paper on which I made little grid lines and made a chart and listed, maybe it was 10 pieces of paper, but anyway, it was all hand done. And it was all species and natural communities. And there was no landscape scale attention to anything at that time. And there were certainly landscape scale conservation projects, like the place I was working, like Great Loss Island or Kata, in Baxter State Park, Green Mountain National Forest, Cape Cod National Seashore, there are all kinds of things like that. But the focus was, what are the species and what are the habitats that we need to protect? So it's really evolved quite a bit from there. And I do credit the Nature Conservancy for a lot of that sort of shift in thinking.
And even natural communities. There was a time when we thought mostly about species, and natural communities at some point. I mean, they're not a new concept. They're back in the 40s or 50s, I think, as a concept. But it wasn't until 20, 30 years ago that they really started to take hold as a tool for conservation. Again, it's kind of small scale. They're like the cedar swamps are 40 acres, and the cliffs are, well, they might be 10 acres if you flatten them out, but they're not very much if they're vertical. So it is a big change.
Art?
Well, thank you, Eric, especially for this call to action. I think in my career, the thing that I've noted, seen, just the availability of satellite photography, I think has really brought things. It's just easier to see what the scale of the farmland is, what the scale of the forest is, and so forth. And so I see that as being maybe sort of a driver, bringing people's understanding of what impacts have been. And 40 years ago, there was no such thing as that picture of the lights
Right.
around the globe, and it's really, really remarkable. So I think that.
I think you could probably extend that art to the flat Earth syndrome and the boat sailing out, and thinking, well, we're going to drop off the edge. And at some point, we saw those first pictures of the full globe
From the moon.
from the moon, and those kind of revelations. And you're right. I mean, just looking for those photos, I looked at the photos. You can see of different things happening. Dust from the Sahara, and going here and creating a new community over there. This stuff is wild.
The overall, the level of mapping, like the maps that you show pictures of, is light years ahead of what there was when you started.
But speaking of, it reminds me of the New England Botanical Club that you had met. When I joined the club, we had just started to make maps of the New England flora, and they were pieces of paper. And people were just kind of rubbing sponges in where the plants were going. They were filed right in the ground.
You remember, Dave, the natural heritage maps when Liz started and I started. They were topo sheets, and you'd have a blue sticky dot, a green sticky dot, or a red sticky dot that was a record, and you'd stick it on the map, and that was the record.
And if
Notes in the
those-
margins.
And the margins.
And
right?
yeah, there were margin notes, and if the sticky dot fell off,
It's
you're
like,
like,
where's it go? Yeah.
I have a question about old forests. I know you've all been working on inventory of old forests, and are a lot of those on private lands? And what is kind of the latest on the best way that you think we can protect them? And is there any regulation on old forests by the state now?
Yeah,
Gee,
let's see.
Bob.
So let's. I think the first part of the question, are they on private land? I think many of the best sites are on public land, and that's probably a reflection of where inventory has happened. There are definitely very high quality old forest examples on private land, and probably more to be found. Does that fit with what you expect?
I think the ones on private land tend to be things like cedar swamps that people have to walk.
or talus slopes or cliffs or.
Right. That's a good point, that a lot of these old forests are not the matrix forest, but other natural community types. In terms of what to do with them, I think if they're functioning and they're not threatened, the best thing we can do is let nature keep driving what's going on there. And if there can be permanent protection for those, that ensures that those functions will continue over time and that continuity of process will continue. There's threats to old forest like invasive species, changes to the surrounding land use that could affect the forest. So there's those kinds of things to deal with. The regulatory protection would have to come. There's no direct protection for old forests. It would come through some other mechanism, like a rare and irreplaceable natural area in Act 250, for example, would probably be the one that might most often be used to protect those. But there's nothing that could stop someone from logging an old forest.
And a mechanism that is not permanent protection, but it's short-term term protection, which is coming into play now, is changes in the use value appraisal program, Vermont's current use program, tax abatement program for protecting forests, and you can protect old forests, not actively manage them under that program, but they're figuring out the detail. It's just brand new, they're just figuring out the details now.
Right, and that actually goes a step beyond, and I think it's really exciting that it's going to provide a way for landowners who are interested in promoting old forests to take forests that are not old and let them get old, or take steps to accelerate the development of old forest structure. And so that will perhaps help reintroduce that on landscape and get us closer to that target in Vermont conservation design of about 10% of the forest is old forest.
I think Bob did a pretty cool analysis of that target of 10%. I think we're close to halfway there in terms of lands that will become old. We have way less than 1% of old forests, but if you look at Forest Service wilderness areas or research natural areas or high elevations on state lands that aren't going to be managed, we have a lot that's already on the way there. And so that's sort of a positive side of that, I think. Is that right, about half of the
That's
target?
right. Yep.
There's a new publication that will be coming out in just a couple weeks, which is actually a refinement of an older publication, but it's one that I've been working on with all of you and other people on managing for old growth forest characteristics, which describes how different ways to get old growth characteristics on your land, including leaving it alone, doing nothing, or as Bob said a minute ago, sort of doing some things to maybe accelerate some of those features, like getting some wood on the ground, getting some of those standing dead trees like I showed you in the Williams Woods, and things like that. And we're doing workshops on it. We've got a workshop coming up next week on it, trying to get the word, just get the word out on that.
So I, like Art, so appreciate your call to action, and I loved hearing about this work in Vermont, and I think you're probably quite familiar with some similar projects in Maine, beginning with Habitat, in Massachusetts, the Biomap. And I'm just wondering if you're aware of cross-state efforts to try to collaborate to increase those regions of connectivity and landscape scale conservation. I know the Nature Conservancy works across the region and really globally, but I'm wondering if NatureServe Network or the state government agencies are perhaps thinking to collaborate across the region to try to connect these various amazing mapping efforts that have taken place.
A couple of things come to mind. One is something like, in addition to the Nature Conservancy, that Staying Connected project is a regional one looking at connectivity, which it's fairly narrow in its focus. There have been some other efforts, I can actually say this tonight, by the U.S. Fish and Wildlife Service for regional planning that I think are very poor. And
Oh, you can say that now.
I mean, they're not ones that you could take and apply easily, like the Nature Conservancies you could. But there isn't a lot of state-to-state coordination on it. There's that joke about building a bridge across a river, and engineers don't plan well, and it doesn't meet in the middle.
Wouldn't it be great to create a council of some sort, across the state agencies to talk about connectivity specifically, as we're, the issue is only becoming more and more urgent.
There isn't anything like that going on right now, so I mean,
And the Staying Connected initiative is great and does do that, but it is for really the northern Appalachian Acadian ecoregion.
Yeah.
So it doesn't include a lot of New England and New York. So it's a great model, I think, and that other large ecoregions or groups of states could do similar projects together.
We've talked about how NatureServe, the nonprofit organization that serves as an umbrella for natural heritage programs, they collect the data on rare species, they collect the data on natural communities, and the landscape scale would be one way that's another possible place where that data could be combined
Right.
in aggregate.
Just a little anecdote that, do you remember there was a catamount that came from out west and somehow made it to Connecticut a few years ago, and I think it was hit by a car? The map that Mark Anderson did of landscape connectivity, you could follow the path of where the catamount had been sighted, and one of the sightings, I forget what major highway crossing it was, maybe in 87 in New York or something like that. It crossed right at one of Mark Anderson's landscape connectivity points. And I called Mark and said, it's working, it's working, it's working.
Thank you all so much.
Thank
for
you so
listening.
much, thank you.